Hello students, welcome to BTech first year physics course. In the last lecture, I have introduced the concept and definition of line integrals. And we have also discussed the concept of gradient and using that the conservative property of any vector field. Right? Now today I shall discuss different problems and their solution related to line integrals. Okay, so let's start with first problem. If a vector is like this, then we have to evaluate the line integral of the vector A along these following paths. Now in question A, these forms of x, y and z are called parametric equations because these coordinates are dependent on only one variable, that is t, and they are related by these equations. That means only defining t we can define each and every point on the space by these equations, right? For example, here t varies from 0 to 1. So these 2 points correspond to 0, 0, 0 and 2, 1, 1 points respectively in 3-dimensional Cartesian coordinate. That means we have to find out the line integral along a path which starts from 0, 0, 0 and ends at 2, 1, 1 point. Okay. Then in the question B, the line integration has to be performed from 0, 0, 0 to 0, 0, 1, then to 0, 1, 1 and then to 2, 1, 1 point. And in question C, the straight line joining 0, 0, 0 and 2, 1, 1 points. Right? So, first let's write the line integration form. Here the vector field A is of this form and dr is I dx plus j dy plus k dz, which is elemental length along the curve. And after dot product we get this. Now putting the form of x, y and z in terms of t, we get this integration. Right? Now you can see the integration becomes with respect to the single variable t and it varies from 0 to 1. Here the lower limit is 0 and upper limit is 1. Right? So as a result, our life becomes easy to solve this integration because here is only one variable. Right? And finally, putting the limits, we get this form. Right? Now in question B, first we have to perform the integration along the straight line from 0, 0, 0 to 0, 0, 1. And here x and y equals to 0. Also dx and dy will be 0. While z varies from 0 to 1. Then integral over this part of the path will be 0. Right? Then along the line from 0, 0, 1 to 0, 1, 1, here x equal to 0, z equal to 1, dx equal to 0 and dz equal to 0. Right? While y varies from 0 to 1 and the integral becomes 0. Now along the line from 0, 1, 1 to 2, 1, 1, here y equal to 1, z equal to 1, dy equal to 0 and dz equal to 0 and x varies from 0 to 2. Then the integral will be 10. So in total the value of the line integral along the straight line from 0, 0, 0 to 0, 0, 1, then to 0, 1, 1 and then to the last point to 1, 1, the value will be 10. Right? Now along this straight line, to find out the integral, we can use this parametric equation to make the integral easier to solve. Okay. So if we do that, the lower limit of the variable becomes 0 and upper limit is 1, right? Then after doing the integration and putting the limits, we get this value. So in this problem, you have learned how to solve line integral along different paths using possible parametric equations, right? Now let's discuss the next problem, which is if the force field is like this, then we have to evaluate the line integral or work done along the curve which is y equal to x cube from the point 11 to 28. So since the integration is performed in the xy plane, or we can say y equal to x cube curve is situated on xy plane, z will be 0, and we take r vector is x I cap plus y j cap. Then we get this form of integral. Now let's substitute y equal to x cube in the integral, and here x varies from 1 to 2 because here this corresponds to 11 and 28 points respectively, and this is given in the problem, right? And after doing the integration and putting the limits, we get this value. Okay. Now let's discuss a problem where we have to evaluate the closed line integral f dot dr, where f is of this form: x minus 3y I cap plus y minus 2x j cap, and the closed curve C is in the xy plane, and the parametric equations are like this: x equal to 2 cos t and y equal to 3 sin t, and t varies from 0 to 2 pi. So as the curve is in the xy plane, z equals to 0, right? So the integral can be written like this, and we have to solve this closed line integral. Okay. Now before solving that, let's understand those parametric equations. Now if we plot them in xy plane, it will be like this ellipse, and the line integration has to be done along this closed path C, and that is the circumference of this ellipse, right? Now here if we travel along this path C in counterclockwise direction, then we will call it positive direction, and the clockwise direction movement will be as negative direction. Okay. So accordingly the sign of the integration will vary, right? Now let's substitute the parametric equations in the form of the integral, and we get this. And if we solve the integration and put the limits of the variable t, that is 0 to 2 pi, then we get this value. And here the 6 pi value what we get actually indicates that we have considered positive direction of movement along the closed path, right? Now in the negative direction the value will be simply minus 6 pi. Now let's discuss one problem which involves the concept of gradient, and from there we have to evaluate work done by this vector field or force field, which is of this form: y square cos x plus z cube I cap plus 2y sin x minus 4 j cap plus 3x z square plus 2 k cap. Now first we have to prove that this vector field is conservative field. So for that the necessary and sufficient condition is curl of that force field will be 0. So let's verify that whether the force field is conservative or not. For that first we have to write the form of curl F, and that is like this. So it is similar to vector A cross B. and instead of a vector here we have del operator, right? And these are different components of a vector. Now if we do the operation of partial derivatives, then we get this form, and we get the value of curl F is 0. Okay, thus we can tell the given force field is conservative in nature, and for that it can be written as F equals to del phi or gradient of phi, where phi is a scalar potential or scalar field, right? Now we have to find out that scalar potential associated with the given conservative field. Okay, so as F equals to gradient of phi and the form of del operator is like this, I cap del del x plus j cap del del y plus k cap del del z, we can write this equation, right? Now let's compare each component of the force field and we get these equations, right? Now to find out the phi, we have to integrate these equations, and after integrating these equations we get this form of phi. Now as the equation 1 is derivative of phi with respect to x, keeping y and z fixed, then integrating this we get y square sin x plus xz cube plus fyz. Now what is this fyz? So this is the function of yz. So as the integration with respect to x and y and z are fixed, then we will get an integration constant which will be function of y and z. Now similar for others. Okay. Now here we can see that the forms of the scalar potential are different, right? But the scalar potential is single valued. So those different form of phi agrees if we choose fyz equal to minus 4y plus 2z, g xz xz cube plus 2z, and h xy y square sin x minus 4. Okay. So final form of phi will be y square sin x plus xz cube minus 4y plus 2z and one integration constant that is arbitrary, right? So again I am repeating this part, how to find out the scalar potential from these equations. So listen carefully. So first you try to find out the common term in these expressions. Okay, so here and here y square sin x is common, so let's write that. Then here and here xz cube term is common, so you have to write that. Now there is minus 4y term which is not present in other expressions, so you have to consider that separately, and I have written that here. Similarly the 2z term. Okay, and we get this final expression like this. Understood? Now to find out the work done in moving an object in the field F from a point P1 to P2, we have to perform this integration. Now as the force field is conservative in nature, we can put gradient of phi in place of the force field F, right? And we get integration P1 to P2 del phi del x dx plus del phi del y dy plus del phi del z dz. And this term is actually d phi, which is called differential of phi. And the expression of phi we have already obtained, that is y square sin x plus xz cube minus 4y plus 2z and arbitrary constant, right? Now after integration we get this. So this is similar to integration of dx, right? If you do the integration of dx, what you will get? You will get x. So similarly here, integration of d phi, you are getting phi, and the expression of phi is like this. And here the points P1 is 0, 1, minus 1, and P2 is pi by 2, minus 1, 2. Now putting these values, we get this value of work done. Okay. So here one important point you should remember, that as the force field is conservative in nature, work done is path independent, and the value is potential difference between the final and initial points, right? So today we have done solutions of various types of problems related to line integrals, gradient of scalar potential, and conservative property of vector field, right? And I strongly believe that you have acquired many important concepts and procedure of how to solve problems related to line integrals of vectors, right? So today I stop here. In the next class I shall discuss about surface integrals. Okay. So thank you for attending today's lecture. See you in the next class.